Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Let's see example 10. We are asked to write a sentence on a suitable surface using a piece of chalk that is poor calcium carbonate. Calculate the number of carbon atoms in your sentence. Let's see the solution. Using a balance, we find the mass of the chalk before and after use. The difference of the two masses is the mass of the poor calcium carbonate. We used from the mass of calcium carbonate, we find the carbon atoms in our sentence. We know from the molecular formula of calcium carbonate, 1 mole calcium carbonate contains L carbon atoms. L is Avogadro constant. The mole of calcium carbonate we used is equal with the value of mass divided with molar mass. In this mole of calcium carbonate, we have the N carbon atoms which we want to find. So we have the relationship or this is the carbon atoms in your sentence. Let's pass to the fourth category. We study the empirical formula. Empirical formula gives the simplest whole number ratio of the elements in a compound. Let's know experimental empirical formula determination. Here is methodology. Methodology. Step 1. We write the amount of each element in a given amount of the chemical amount. Step 2. We divide each element amount with the corresponding molar mass. Step 3. We divide the new results by smallest, and we write them in nearest whole number ratio. Let's see some examples. Example 1. 36.036 grammar of an organic compound contains 14.412 grams carbon, 2.424 grams hydrogen, and the rest is oxygen. What is its empirical formula? Let's see the solution. First, we must find the mass of oxygen. For this, from the mass of organic compound minus the mass of carbon minus the mass of hydrogen, and this is equal 19.2 grams. Let's see how we find the empirical formula. First, as we said in methodology, step 1, we write the amount of each element in the given amount of chemical compound. Here's carbon, hydrogen, oxygen. So we have amount of each element, the amount of carbon, the amount of hydrogen, the amount of oxygen. This is step 1. Step 2. Each amount divided by molar mass of element. So we have the mass of carbon divided by molar mass of carbon, and this is 1.2. The same, the amount of hydrogen divided by molar mass of hydrogen is equal 2.4. The same for oxygen, the mass of oxygen divided with molar mass of oxygen, and this is step 2. Step 3. The results we found, each result divided by smallest. the smallest is 1.2, and we have the result is 1, the result is 2, and the result is 1 for oxygen. So we have whole numbers results. So the empirical formula for the organic compound is carbon, hydrogen 2, oxygen. This is example 1. Continue with example 2. We have the percentage by mass of carboxylic acid is for carbon, for hydrogen, and oxygen. What is its empirical formula? Let's see the solution. We follow the 3 steps. In the first step, we write the amount of each element in 100 grams of the organic compound. Step 1. Amount of each element in grams. We write the number of grams for each element, and then in step 2, divide its mass by molar mass of each element. So we have for carbon, we divide it by 12.01. For hydrogen, the result is 9.06, and for oxygen, the result is 2.27. In step 3, divide its result by smallest to the nearest whole number ratio. In the previous example, we have whole numbers results. So we have 4.54 divided with 2.27, and the result is 2. For hydrogen, the result is 393 equal with 4, which is the nearest whole number ratio. And for oxygen, the result is 1. So, the empirical formula is carbon 2, hydrogen 4, oxygen 1. This is the second example. Let's have the third example. Example 3. A 7.2 grams sample of an organic compound that contains only carbon and hydrogen was burned in excess oxygen. The products were 22 grams of carbon dioxide and 10.8 grams of water. Determine the empirical formula of the compound. Let's see the solution. In this example, we don't have exactly the amount of carbon and hydrogen in the given mass of organic compound. We must find first the mass of carbon from the mass of carbon dioxide and the mass of hydrogen from the mass of water, which are products of combustion. We have carbon dioxide grams, so we need MR. MR is equal AR of carbon plus 2AR of oxygen, and the result is 44.01. And we have the relationship between the amount of carbon dioxide and the amount of carbon. 1 mole carbon dioxide or 44 0.01 grams carbon dioxide contains 12.01 grams of carbon. In 22 grams of carbon dioxide, we have M1 grams. So we found the grams of carbon which contain in the 7.2 grams of organic compound. And the result is (6.03 grams of carbon. The same for water. We find that MR is equal 18.02, and for the molecular formula we take the information. 1 mole water is equal 18.02 grams of water, contains 2 times 1.01 grams hydrogen. Now we have 10.08 grams water and M2 grams of hydrogen. So we find the mass of hydrogen in the amount of organic compound. So we have and the result is 1.21 grams of hydrogen. So we have the amount of each element. Let's continue with the same way for the empirical formula. We have 2 elements, carbon and hydrogen, and in step 1 we have the amount of each element. That is 6.03 for carbon, 1.21 for hydrogen. Step 2. Each result we divide by molar mass of element and we have the result is 0.53 for carbon, and 1.14 for hydrogen. And in step 3 we divide its result by smallest. So we have one for carbon, and 2.15 for hydrogen, and the nearest whole number is 2. So, the empirical formula is carbon 1, hydrogen 2. Let's see example 4. An acid has empirical formula hydrogen, sulfur, oxygen 4. And the molar mass of 194.16 grams mol -1. What is its molecular formula? This is solution. You see, from empirical formula, and molar mass, we can find the molecular formula. Let's see. From empirical formula, hydrogen, sulfur, oxygen 4, we find the mass. Ar for hydrogen plus Ar for sulfur plus 4 times Ar for oxygen. This is equal 97.08 grams mol -1. Apply. The mass from empirical formula times V must be equal with molar mass. So, we have the value of N, which is 2. So, we have the molecular formula, which is hydrogen 2, sulfur 2, oxygen 8. You must remember that the empirical formula have the smallest whole number for each element, but the molecular formula has the exact number of each element in the molecule. This is the mole concept. We'll continue with next chapter. I hope to help you. Thank you for watching. Thanks for listening, and more IB chemistry videos to come. If you like the video, and you can support me on Patreon. Thank you.